So these programs that you can create for programming language can range from large constructs, such as an operating system like Mac OS or Microsoft Windows, which have like 50 million lines of code. Or it can be like a small program like your desktop calculator, which takes a few dozen lines of code. And all of these programming languages can be, all of these programs can be written in programming languages, any kind. There's roughly about 700 programming languages. But what makes Python so special out of these near 1,000 languages? Well, firstly, Python is extremely flexible and versatile. With small amounts of code, you can create very complex programs that complete very complex tasks. And these tasks can range from automation, data analysis, creating artificial intelligence, web design, and robotics. So, and on top of this, Python is also cross-platform, which means it can be run on nearly any computing device. And so due to this versatility, Python is one of the fastest growing programming languages in the world, and it can be used in nearly any vocation. So as long as you sort of name a job, Python can be used in it, such as, accounting, data analysis, banking, visual designer, just any area. Now, alongside this, it is great for beginners because it is very close to a natural language. Where some programming languages are closer to a machine language, which are harder for humans to interpret, Python, as you will see, is very close to a spoken language, and as such is quite easy to learn. And that's why we chose it for ExCode this year. Okay, now I'm going to sort of quickly go over how a programming language such as Python works. You don't need to remember any of this. It's just a bit of a background, 30 seconds of really how it like gets from code into a runnable program. So it starts like with us, the programmer, writing a computer code, which, as I said, is just a set of commands one after the other. And once we have finished, we pass this code into an interpreter, which is just a computer program that directly executes instructions that are written in the programming language. And what this interpreter does is it checks every code line by line, starting from the top, working the way down, checking for such things as spelling mistakes, illogical statements, etc. And if it encounters an error, it halts and it will show an error message and it won't run the program. I have to go back and fix everything. But if no errors are encountered, the code is written and formatted correctly, then it sort of translates it into another language, which is called a byte language. And then this byte language is run on a virtual machine and the program's run. Obviously, I said you don't need to understand that. It's just more how you get from you typing stuff into your IDE to actually creating a program. So let's get started. When we like set you off to do your own stuff, you'll be working on this same file format that I'm using. It's called Google Colab. Your teaching assistants will explain how to get it and how to use it and everything. So programming rules follow a set of, programming language follow a set of rules that tell us how code must be written in order for the computer to understand it. So this program, like these set of rules are called syntax. And syntax must be followed exactly. So for instance, if we were to sort of set out and start with a random program, really simple, and be like, I want to print the words, I go to Exeter University onto the screen. The computer won't be able to understand that. It have to write it in its own language. So if I try to run this, so run it through an interpreter and et cetera, make it into a program, it'll take a second to load. It'll come with a syntax error because I'm not following the rules of Python and how its language is constructed. So just like any other human language, which has like grammar and spelling, so does Python. So if I want to do this, I want to print the words I go to Exeter University on the screen, I have to write this. Print, I go to Exeter University. And it should print that onto the screen. Now, as I said, syntax must be perfect. Otherwise, it won't be run. So for instance, if I were to put a capital letter on print, it would throw an error. If I were to misspell print and put pint, then it would throw another error. Or if I were to miss out a quotation mark, it would throw another error. Things must be written perfectly in Python, otherwise they won't run. Furthermore, if you want to have multiple commands, as I said, a programming language is simply just a set of commands, one after the other. You have to write every new command on a new line. So let's say I wanted to print out, this is going on the second line. I'd write it on this new line. So I've given it one command on the first line, another command on the second line. If I were to give it a third command, I'd put it on the third line. Every command must be on a new line, otherwise the interpreter can't actually understand it. So for instance here, if I try to put this on the same line, so two commands on the same line, it would run into an error again, invalid syntax. So every new error has to be, every new command has to be on a new line. Now, as I said before, everything must be written absolutely perfectly. But one way, if you have an error and you, well, this is, you'll see this throughout whenever later on, but I add something called a comment. And a comment does is it cuts something out from the code. So if I were to put a hashtag here, which means comment, everything on that line after the comment won't be run by the machine. It's just for your own personal sort of checking of the data. So if you want to make a note or there's a piece of code that doesn't work and you don't know what to do with it, you put a hashtag in front of it, and then when the program tries to run, it will just completely ignore the whole line. Okay. So now once we've gone over the idea of syntax, this is how you write something onto the screen. So print, the keyword print, bracket, Colab will create two brackets when you type in one bracket, quotation mark, and whatever you want to put in the brackets. You might have noticed that every time we print, it goes onto a new line. You can sort of simulate this and create a new line wherever you want by doing \n. When you run that, it will print everything after \n onto a new line. Just a quick tip. Now, moving on to variables, because we need to have sort of containers that hold data values so that we can sort of manipulate and do important things with any sort of data we've gathered from anywhere, basically. So variables are simply containers that hold data. Think of how you're doing algebra, and it'll be a plus b equals c. And then, for instance, you go a plus 2 equals 10. You guess that a is 8. These like a and b and c, they all hold values. So in a sense, they're like a container. So these containers can be accessed by us. So what we do is we get a container called a variable, we assign it a value, and then later on we can use it how we wish. So I'll just give you a quick example. So for instance, if we're writing a sentence like this, so I live on Monks Road, it is 20 minutes from campus. Although I live on Monks Road, I wish it didn't take 20 minutes towards campus. So if I run that, it prints all that out nice and neatly. However, what happens if I live on Vic Street? And Vic Street, and that's 5 minutes from campus. If I live on Vic Street, and it's, I don't know, 5 minutes from campus, I'd have to change it everywhere if I'm like, just, you know, for each different person, I have to change it everywhere. So I'm changing the values everywhere within the document. I don't want to have to do this because I might have to process loads and loads of pieces of data and loads of different people who live on different streets, takes different time to get to campus, etc. So this is where variables come into play, because I don't want to rewrite this every time I run the program, or when I just iterate through doing it over and over again. So we create a variable or a container to hold these values. So if I were to have, house, street name. So this is my variable, street name equals, let's do Monks Road again, Monks Road. And I'll do travel time equals 5 minutes. Okay, so now whenever I refer to the word street name, it will return Monks Road. So I'll quickly put this in here. I live on Vic Street. And if I were to replace this quickly, let's put this variable inside the print. So what I'm doing is here, is I'm putting the variables inside the print statement so that whenever I change the variable's value, it will change here. So if I run this again, I'll see I live on Monks Road. Now what's happening here is I'm going print, I live on, and then it goes plus street name. So what it does is it goes back to where street name was made and it looks what value it has. So it has Monks Road. So it says, it replaces street name with Monks Road. So as you see in the output here, I live on Monks Road. Now, if I go to print, it is plus travel time plus from campus. What it does is it goes and finds travel time and sees the value that's applied to it. So it replaces travel time with 5 minutes. Now, you can use this multiple times anywhere. All it is basically just calling a container. So you've stored a value in that container, and whenever you reference it, you use the value that's inside that container. That's simply what a variable is. So you can change these values for anything you want. So Vic Street again. And it was 5 minutes, but let's just do 10 minutes, even if that's not true. If I run the program again, you'll say I live on Vic Street and it's 10 minutes from campus. So you can change these variables to have a different value, and when you do, it will sort of apply to the program. Now, if you've made a variable, you can also change it as well. So let's say I live on Vic Street now, but then I move on to a different street. So as I said, Monks Road again, and travel time equals 20 minutes. And if I run the program here, you'll see that the first one says I live on Vic Street and it's 10 minutes away. But the second one says it lives on Monks Road and in 20 minutes from campus. So what's happened here is it's looking for street name. So it finds the most recently updated street name, which is Monks Road. And the same applies here. It finds the most recently updated version of it. So I've put Vic Street in initially, and then when it comes down here, it takes Vic Street out and puts it back into the variable, puts Monks Road into the variable, and it takes travel time and it puts 10 minutes in. And when the second time we encounter it, it takes the 10 minutes out and puts 20 minutes in, so that now it refers to these. Okay, now we should probably go into variable names. So as I listed, variables are containers. So variables can have any name you want as long as it's a single word, it's not a keyword, and it has and it's case sensitive. So street name, absolutely fine. You can use underscores to represent spaces if you want to. But for instance, we can't have a variable called print, because print, as we saw above, is already like a keyword. We already use it here. So we try to use that would be a problem. For instance, if I tried to use travel time and then use space and then do that wouldn't work either, because you've used a space, which isn't allowed. Instead, you'd have to use, as I've done before, an underscore. And variable names will have to be unique, because as you've seen here, if you use the same name again, it will just overwrite the previous value. Now, I've been working with what are called string variables here, which are encased in quotation marks. As you've probably noticed from the print statements, when you print something, it's encased in quotation marks. This is because what you're doing here is you're basically printing out a temporary variable when you do this, called a string variable. And a string variable is basically a text variable. There are other types of variables, as we'll go through now. So there are integer variables. So integer variables hold whole numbers. So let's do test variable equals 42. So that's that holds the value 42. This isn't the same as the value 42 like that. So this Python sees as an actual number, whereas this, in case in quotation marks, it sees as text. So when you try to sort of add numbers together and sort of manipulate them, it won't understand when you use this, because it thinks you're basically writing it text, like a message, basically like a sentence. It doesn't know what to do with the sentence. It can't add a sentence to a sentence or multiply a sentence to a sentence, etc. It's just a bit strange. So you need to use this, a number 42. Now there are other variables. There is a variable called a float. Now a float is just another number, but it's a number that has a decimal point. So 42.0 is technically a float. This you could do 0.54535 or negative 0.0345. Doesn't matter. This is just a different variable because it allows decimal points, whereas integers don't allow decimal points. And now the third type of variable is known as a Boolean variable. Boolean means like true or false. So this kind of variable can either only ever be true or it can be false. I'll only mention it now, but we'll go into it in more detail later. And then the fourth one, obviously, as we said, was a string, which is something that's text and it's encased in quotation marks. Now, you might ask, how do you differentiate them? Well, Python knows what you mean. So when it sees just a raw number as 42 assigned to a variable, it knows that it's an integer. It knows that you want to be using whole numbers. So that variable there is automatically set to an integer. Same applies to a string. It's got quotation marks around it, and it knows that it's a string, or a set of text. The same applies to float. If you've got a decimal point in there, it knows that it's a float. It's a decimal number that you want to be working with. And finally, with a bool, if you type in false or true with a capital letter, it will know that you're talking about a Boolean variable. You don't have to worry about those at the moment. Now, so you can print these variables out on the screen, as you saw, but there is a slight difference when you're printing out different kinds of variables. So as we said, as you saw up here, when you have a string variable and you put the string variable inside a print, you do the text that you want, you end the quotation and use a plus and then the variable name. And then even if you wanted something afterwards, you do plus and then your own text in quotation marks. This is because, as I said before, when you're putting these things in print, they're actually temporary string variables. So what you're doing here simply is adding a string to another string, and then you're adding that string to another string. So you're sort of adding three variables together, a temporary one, a sort of a permanent one, and then another temporary one. But this is slightly different when you're using variables that aren't strings. So if I were to print the number 42 follows, I get outside of the quotation marks, I use a comma, and then I use the variable name. So if I use test underscore var, which is referred to as 42, and I run this, it should put down 42. It won't work with the plus as it did with strings, which have quotation marks around them. It will throw another error. You have to make sure you use a comma when you're using anything but strings. So if I were to replace this with test variable 1, it would work because test variable 1 is a string. So it allows to plus a string to a string, like you're just basically adding two pieces of text together. And the same applies to floats. If you go print and then the number, whichever number this is, comma, and then test variable 2, which is this one, you have to use a comma as well. Oh, I have I've misspelled print. There we go. Sorry, as you see, syntax has to be perfect. It prints out that as well. So as long as you're not using text, you have to use a comma to print out a variable. Okay, now there's not really much point to having variables if we can't really actually do much with the variables. So we'll just go through the really simple ones, which are plus, minus, multiply, and divide. These are the only operators we'll go through on this session. So how do you do this? So we'll start off with print. So I can print 4 plus 4. Obviously, you understand that that's most probably just going to be 8. It's going to print 8. So you can print things with the plus symbol. But you probably want to actually apply these to variables as opposed to just printing them like blindly onto the screen. So let's do a addition variable. So let's do addition variable and let's assign to it 6 plus 7. So now that variable, what it does is it looks to the right of the equal sign. So it does 6 plus 7, which is 13. And then it looks to the left of the equal sign and it applies that to this. So now addition variable is now 13. So if I were to print addition variable, it'll come out as 13. Now I can multiply these as well. So 6 times 7, I print that, 42. So for multiplication, you'd use an asterisk. Okay, you can also minus them. So 6 minus 7, I can print that out as well. And that'll come out as -1. And you can divide them as well. 0. Blah, 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 blah. Now, one thing I have to think about is interacting with multiple different types of variables. So actually, no, I'll move on to that a little bit later. So what you can do is if we were to assign a variable, so if we do number 1 equals 45, number 2 equals 55, and do number 3. Now, you can also use variables to assign different values to another variable. So for instance, if I want to assign the sum of number 1 and number 2 to number 3, I can simply do number 3 equals number 1 plus number 2. Now, if I were to print, new line, print number 3, come out as 100, which is 55 plus 45. I can multiply that, etc. Gets the number. So you can use variables to get to create new variables. Another thing you can do is you can also use the same variable to create another iteration of itself. So let's say you have number 4. And number 4 is given the value 65. Now, let's say later on you realize that you wrote that wrong, and actually imagine you actually every time you come across this number, you have to add 5 to it. So you do number 4 equals number 4 plus 5. Now what this will do is it will go from, so I said you look from the right of the equal sign and you apply it to the left. So in this case, what it's going for is it's looking for number 4. Now the last time number 4 was assigned, it was 65. So it replaces that with 65 and then it pluses 5, so it's 70. And then it applies 70 to number 4. So basically it's updating its old self. So if I were to print number 4, it should come out with 70. Yes, with 70. So you can update the variables themselves by sort of referring back to itself. Obviously, you can also, as you can with maths, you can do multiple operations in one go. So we could add 5 and then multiply it. So we should get to like 140, like that. Usual just mathematics rules with brackets, etc. Yeah. Another thing, as we saw with strings, so let's do test text, and then let's apply the words, actually test text 1, apply the words unfinished unfinished sentence, and then we do a text 2. And what we can do is we can do, we could set text, the second text as text 1 plus tense, and then print test text 2. So what this is doing is I'm creating an unfinished sentence text, and then I'm creating another string, which is the first string plus tense. So if I print this out, it should say unfinished sentence. So you can add strings together as well. So you can, they're the same sort of variable. So you're basically adding one string to another string, which is exactly what we're doing inside print up here, we were adding strings to strings and to strings to strings. You can add sort of text together, just glue it together. Now, there's an issue arises when you try and interact. So you try to use different data variables to interact with each other. So as I said before, it's weird if you try to add a number to a sentence, to a string, it won't understand what to do. How can you add 45 to the word dog? It doesn't make sense. So what will happen here is if I do test text, and let's do test text 3, and we just give it the word dog. And then we have test number 1, and we assign it the value 45, and then we try to print out the result of test text 3 plus test number 1. So as you see, there's an error thrown because it says must be string, not integer. So what's basically happened here is it's tried to add the text of dog to the number 45, but obviously it doesn't understand this because there's two different variables. Like how do you come to a conclusion of how you add those two together? So it just throws an error and it just stops. But there are some ways of getting around this. So for instance, let's say we have the test text actually holds the value 67. Now, if we try to print that out again with test text 3 and then plus test underscore number 1, test text 3 number 1, still throws an error. Even though 67 and 45 you'd think might be interchangeable, and we'll be able to sort of, figure it out, because even though that's just text, it's still a number. So you might think 45 plus 65. But the thing is, the computer doesn't know that that's actually a number. It still thinks it's text. So there's a way of getting around this, and it's called casting. So what you do, let me just quickly work it around here. Sorry, I have done that wrong. Sorry, we'll do this with a different number because that one's going to be more difficult. So for instance, let's say we do test float 1 and we put a value of 45.6. So it doesn't understand how to add a float to an integer because it doesn't understand how to add two different data types together. So adding a decimal to a number, it doesn't know how to do it. So we have to find a way of sort of allowing it to do that. So we do test number, and let's do test number 2 equals test underscore number, test underscore number plus test underscore float 1. Yeah, so if we put this to an integer, yeah, okay, it's run as if I want to print it out. Sorry, test number 2. You'll see it's add up to 90. Even though these two things are different kinds of variables, what I've done is I've told the computer to actually treat this float or decimal number as an integer. The way I've done this is I've used the word int, which stands for integer, and I've put it in front of what's it called? In front of the float variable. So int and then bracket and then the variable name, which is test float. And from then onwards, it's treating this as an integer. So it turns 45.678 into just 45. So it rounds down. So it's going from 45.678 plus 45 to 45 plus the integer version of this float, which is 45. So it's gone to 45 plus 45. So that equals 90. The same, you can do this for other things. I believe on the example sheet that I've given you, you'll see different kinds of casting. You just need to make sure that when you do cast things, you use the right sort of casting manipulation. I've used in the examples, I've given all the correct ones. But I'll just go through a couple more. So let's do test number S, test number big S equals, let's do that again. So 68 and then we'll add it again to the test number 1. So as I said, this is text, it won't work. So what we need to do is we need to do new number 3 equals the original test number, which is this one, test number 1. Add it to 68. As I said, 68 is a string, so we want to treat it as an integer again. So we go integer and then test number z. And if I print that out, new underscore number 3, you get 113. So what this is doing here is it's getting the test number 1, which is 45, and then it's adding it to the integer version of this. So although originally the computer couldn't understand what 68 as text was, we're now forcing it to understand it as an integer. So it's generally just doing the same addition as it would if we were to see the number 68 and the number 45. This doesn't always work though. So if, for instance, I had the test number, but someone put in the words hello, and I tried to then add hello, but as an integer to test number 1, which is 45, it would throw an error because it doesn't know how to convert hello to an integer. It just throws an error and it just stops. And as I said, it won't be run as a program. So yeah, so that can be applied when you've got loads of different kinds of data together, but they're not cohesive. Maybe someone's just, you know, not set to the rules and sent you the wrong kind of data. Okay, well, that should be everything from me for this session. So most of you, or all of you, should have been added to a Facebook group chat with some teaching assistants. I know this is a lot that I've gone over, and maybe the last couple, especially the casting, might not have been well explained or is quite difficult to understand. So please, after this, we'll end the call and your teaching assistant will send you another Zoom link, which you can join, and you'll go through some exercises. And please ask them any questions you have, because this is a lot of information in, I don't know, 35 minutes that I've given. So yeah, they will also send you this exact same sheet, but where I've just written random code, they'll have examples with comments explaining it. And then you'll work your way through these 7 or so questions. Yeah. And just in case, I believe on some of the forms, it was said that a prerequisite to this was to have a Gmail account. You can quickly start create that when you just join your respective smaller groups. It shouldn't take too long if you don't have one. So yeah, I believe that's it. I will end this call now, and